Okay, sports fans, what's up next? So, in 7.2, Trig was our problem. Trig was part of the problem that we were trying to solve. This time, Trig will be part of the solution. Okay, let's talk more math. So here, just an example, u equals 1 minus x squared will in fact work here. How do I know that without calculation? Well, if you see an inside function, say u, and you see outside, you see a multiple of u prime, which I do. Okay, u prime is minus 2x, and in front I have x. So if you see an inside function u, and then outside, directly outside, you have a multiple of u prime, that tells you that a u sub is going to work perfectly. Okay, but what do I do if that x is taken away? Well, you may want to pause and try to do u is equal to 1 minus x squared just to convince yourself that I need some new ideas here. So what I'm going to do is make use of trig identities. I guess the motivation here is to say, 1 minus sine squared is equal to cos squared, right? So if I have that under the square root, then I can actually make my square root disappear here, right? So this is what I started with. This is the square root down here. And I'm going to do x is equal to sine theta. And I'm going to make use of this simplification. Okay, we're going to impose some restrictions on theta. I don't expect you to understand what these are there for. At this level, I think it's a detail that's better left alone. But if you're interested, have a look in your textbook. We will plow forward. X is sine theta. So what do? I do a derivative, right? I'm doing something different here. I'm introducing a new variable, theta. But it's appearing on the right-hand side of my equation instead of on the left-hand side. So this is sometimes called an inverse substitution. Anyhow, take a derivative of both sides. You get dx d theta is cos theta. So we get, solving for dx, we get cos theta d theta. Now what we're going to do is do our usual substitution idea. You take this and you take this, you plug it back into your original. And what do you get? You get that. So dx became this, and then my x squared becomes sine squared. Okay, now I'll use the magic of trig identities to reduce this all the way down to just cos squared theta. So pause and copy all this stiff. Okay, in the bracket here, I explain what happened to root 1 minus sine squared. Again, there are some details that I'm not getting into here, but if you're interested, you can have a look in the textbook. There's lots more discussion there. So essentially, I get cosine here, and I got the cosine here, so I get cos squared. Pause and copy. Cosine squared from 7.2, we know that this should be replaced using a trig identity. Identity, enunciate. And you break it up as usual. So up to here, it's pretty standard. We've seen that kind of thing before. I take a step to replace sine 2 theta with 2 sine theta cos theta. And we'll see why right now. Well, the original question was in terms of this variable up here, x, right? So I want my final answer to be in terms of x. Now this is a little bit tricky to switch back to x. So what I'm going to do, I'm going to remember that x is equal to sine theta, and I'm going to get some mileage out of that. So pause copy. Now, x is equal to sine theta. Okay, and x is just x over 1. Now you'll remember that sine theta is opposite over hypotenuse. Okay, so you can draw a hypothetical triangle here with your angle, your x, and your 1. And then to find this side length, we'll say L, you can use Pythagoras, right? So that's red here. L squared plus x squared is 1. So L is equal to square root of 1 minus x squared. Now, what we're going to do now is use this triangle to find, well, we know what sine theta is, right? Sine theta is just x, no problem there. Cosine theta, I can look at this triangle and say cosine is SOHCAHTOA, ka. Cosine is adjacent over hypotenuse. So that's what I write down here. Cosine is adjacent over hypotenuse. Pause and copy if you haven't done so already. Cosine is adjacent over hypotenuse. This is my original choice I made way above there. And if you solve this rectangled equation for theta, you get theta is arc sine x. So I have all this information collected here, which I'm going to use to convert this guy into an expression involving just x. And there you have it.